This is the Enhancing Virtual Machine Protection lesson. This is the 9th lesson in this course. In this lesson, you'll learn how to perform application-aware backups using VMware policies. You'll also learn how to configure NetBackup Accelerator to optimize the performance of VMware backups. This is the Protecting Virtual Machines with Applications topic. Protecting virtualized instances of enterprise applications like databases presents unique challenges to the backup administrator. The protection of VMware virtual machines is best done using VMware intelligent policies to perform an off-host backup of a snapshot of the virtualized machine. These policies support advanced features like resource limits and dynamic VM discovery. The issue is that the default snapshots used by VADP are not application aware, and so the virtual machine gets backed up in a consistent state. However, there's no mechanism to quiesce the enterprise application or database running on the VM, and therefore no way to guarantee consistency for restore. And so our solution to this traditionally has been to treat virtual machines as physical machines when it comes to protecting enterprise applications. Install the NetBackup client inside the VM, use the appropriate NetBackup agent to protect the database or enterprise app. And the problem there is that you lose the advantages of the VMware intelligent policy. So what's desirable is to have application-aware VMware backups, where we can use VIP VMware policies and still provide for consistent protection of the enterprise application. NetBackup 7.7 has support for application-aware VMware backups using VIP policies for Exchange, SQL Server, and SharePoint. These application-aware backups benefit from all the advantages of VIP and VMware policies, but also provide consistent protection of the enterprise app or database. These policies are very easy to configure and manage. In fact, in many cases, it's a much easier procedure than using the traditional NetBackup agent, and they support GRT for Exchange and SharePoint. The only downside is, although they're very easy to configure, they may not be as flexible as NetBackup agents, and we'll explore some examples of that in this lesson. Here's some considerations when using application-aware backups. These backups are going to use VMware policies, and they're always going to be full backups. There's no possibility to do an incremental backup of the application. Now that is a limitation. This limitation can be mitigated to a large extent by using Accelerator with your VMware policies. An Accelerator, of course, will do a full backup in about the same time it would normally take to do an incremental backup, and that gets explored later in this lesson. Also, remember that installation of the NetBackup client in the VM is required for application-aware backups, where it was not normally mandatory for regular VIP backups. It is also strongly recommended to install the NetBackup VSS provider in the virtual machine. The NetBackup VSS provider is more fully featured than the default VSS provider that ships with VMware tools. The specific functionality that comes into play is the ability to truncate log files. So if you want to truncate logs for Exchange or SQL Server, you must install the NetBackup VSS provider. And it is a good idea to use it anytime you're using enterprise apps using application-aware VMware backup policies. Our support techs have seen instances where the backups are just more reliable using the NetBackup VSS provider, whether or not you're truncating logs. GRT will automatically be enabled for Exchange and SharePoint backups. There is some additional configuration that may be required to support the GRT restores. Here are the high-level steps to configure application-aware backups. First off, if GRT is desired, verify that your configuration supports it. Then install the NetBackup client and the NetBackup VSS provider in the virtual machines. And then, depending on the application you're protecting, there will be some application-aware backup-specific settings. For SQL Server and SharePoint, there's a logon account that must be configured in order for NetBackup to have access to the application. For SharePoint and Exchange, for granular recovery, we'll need to enable NFS on the granular clients. and we'll want to specify the name of the service account that NetBackup is going to use to access SharePoint and Exchange in the client host properties, a process that's similar to the configuration used in physical SharePoint and Exchange servers. And then once these prerequisites are met, we can go ahead and configure our VMware backup policies. Here's a closer look at satisfying those prerequisites. First off, check compatibility. The NetBackup master compatibility list for the version you're using directs you to compatibility documents. In this case, we're specifically interested in the application and database agent compatibility list and the support for NetBackup in a virtual environment document. Then we're going to want to install and configure NFS to support GRT on Windows Media servers, on back-end SQL servers, and that's SharePoint only, and for Exchange granular clients, Exchange only. Here's an example of installing the NetBackup VSS provider for vSphere. This is provided with the software. It's in the NetBackup bin goodies directory where NetBackup has been installed on the client. It's a pretty easy app to install. You just double click on the VSS provider for vSphere shortcut, follow the prompts, perform a reboot if necessary, and then after the reboot, the utility is going to be active. Note that if the VMware Tools software is upgraded later on, the default behavior is for the VMware VSS provider to be reinstalled. That would prevent the NetBackup VSS provider from being used. You'd have to go through and reinstall it again. So to prevent that from happening, do a custom installation of VMware Tools to prevent the default VMware Tools VSS provider from being installed on updates. Another pre-configuration which may be necessary is the Distributed Application Restore mapping. This is located in the master server host properties, and you may already be familiar with this if you've configured SharePoint or Exchange physical server agents. The function here is the same for virtualized Exchange and SharePoint servers as it is for physical servers. This allows you to browse backups and perform restores when the source client is different than the client that NetBackup is using for processing. So for example, in the case of SharePoint, backup images are going to be tagged with the name of the front-end web server. And so you're going to want to use this to map the back-end SQL database servers to the front-end web server. In the case of Exchange, clustered Exchange instances like a DAG, the backup images are tagged with the DAG name, so you may want to make a mapping between the DAG name and the actual component servers, the nodes in the DAG, the actual physical hosts. The biggest use case where you would be looking to do this is in the case of a client-directed restore. That's because you can get hung up on permissions. In the case of a server-directed restore, this is not really an issue because in a server-directed restore, from the master server, your permissions are wide open to restore anything you want, anywhere you want. Note that this applies only to Exchange and SharePoint. It does not apply to SQL Server. Depending on the application you're protecting, there may be some options in the client host properties you wish to configure, again, just as would be the case with physical server protection, and some of them may be required. For example, in the case of protecting virtualized Exchange, you need to enter the service account information in the Exchange credentials section of the client host properties. Here's a SharePoint example. Again, in the client host properties, I need to enter the credentials for the service account that I'm going to use to access the SharePoint farm. Here's an example of configuring a VMware policy for application protection. I'm going to make sure that Enable File Recovery from VM Backup is selected. And then over on the right-hand side under Application Protection, I'm going to check off the application that I wish to protect. And in the case of Exchange and SQL Server, decide whether or not I want to truncate logs or not. Remember that log truncation is only possible if I've installed the NetBackup VSS provider in the virtual machine. Also note that any application protection, Exchange, SQL Server, or SharePoint, requires the NetBackup client to be installed in a virtual machine. The rest of the VMware policy is configured just like any other VMware policy. I'm basically doing all the things I would normally do and just hitting an extra checkbox to protect the application. It's very easy to configure. Here's an example of what goes on during application protection when VMware policies run. Now remember, the idea here is to create consistent full backups of the application. And so what's going to happen is the NetBackup client on the virtual machine is going to take a snapshot of the app. And that's going to happen before the VADP snapshot of the virtual machine takes place. So what you actually have here basically is a snapshot inside a snapshot. There's a VSS snap of the application, so we can capture it in a consistent state, and then the normal snapshot that the ESX server is going to do takes place, and then NetBackup backs up that snapshot. In this example, job 311 runs first, and this is the VMware discovery job. So for VIP policy, as normal, we're discovering which virtual machines to protect. Then job number 312 runs. That's the application state capture, or ASC job. This is what's going to cause the NetBackup client in the virtual machine to take a VSS snap of the application. So the application gets quiesced and snapped, so that we know we have a consistent copy. Then once that has taken place, job number 313 is the ESX server taking a normal VADP snapshot of the virtual machine, the same kind of a snap that would be happening in any VMware policy. We're just snapping the VM and capturing, therefore, that snapshot inside a snapshot. And then 314 is the actual data movement. This is the backup job where the NetBackup backup host reads the snapshot created by the ESX server and writes it to tape or disk. And then after this process is completed, GRT can take place, where NetBackup will index the granular items inside Exchange or SharePoint. This slide describes some general limitations when we're using VMware policies for application protection. As we mentioned before, incremental backups of VMware virtual machines do not allow for application protection. It's got to be a full backup every time. And so that means all of our backups are really point-in-time copies. Now note that Accelerator can be used to increase the speed of our full backups, and the use of Accelerator for VMware policies that do application protection is strongly recommended for that reason. The application state capture job fails if you disable the virtual machine quiesce option or if you exclude data disks. So make sure neither of those options is selected on the VMware tab of the policy. And NetBackup is not going to be able to catalog the application databases if they're stored on RDMs, on independent VMDK volumes, on mount point volumes, RAID volumes, or an excluded Windows boot disk. Here's some application-specific information. In this case, when we talk about restoring Exchange data that was backed up using VMware policies, even though it was backed up with a VMware policy, when you go to restore, in the bar console, make sure you're selecting the Exchange server policy type for the restore, because you want to tell the bar tool that you're looking for Exchange data. All the normal restore options are available. Restoring from virtual Exchange servers is pretty identical to restoring from physical servers. A few gotchas here. In some cases, the primary VM identifier in the policy does not match the NetBackup client name. Always remember to search for the virtual machine with the identifier it was backed up with, which may not be the host name. In VMware policies, it might be the display name, or it might be the UUID. The rule of thumb is use the identifier that was used to protect it for your searches in the bar console. Otherwise, you won't find your data. For restores of an Exchange cluster, select the virtual Exchange server name for the source client. For restores of an Exchange standalone server, the source client name must match the name that NetBackup used for the backup, which again might be the host name, it might be the display name or the UUID. If you want to truncate Exchange logs, like we mentioned before, the NetBackup VSS provider must be installed in the virtual machine. Also, it's necessary to perform a full VMware backup without log truncation first, and that has to do with the way Exchange works. So do a full backup first without the log truncation, then go back into policy and hit the checkbox, and from that point forward, the log will be truncated. Also, in order to be successfully protected, the Exchange databases must be active, mounted, and not in the exclude list. Some limitations that exist when protecting Exchange servers using VMware policies: consistency checks of Exchange will not be performed. Dismounted databases will not be protected. You can't browse or recover granular items from GUID partition tables. And if you want to successfully truncate the logs, you must use the NetBackup VSS provider and first perform a full VMware backup without log truncation. Here's some considerations when restoring SQL Server from VMware backups. Your restore options are going to be volume level restore, file level recovery, or full database restore. You can do an alternate client restore, and that alternate client restore can go to a physical or virtual host. It's pretty flexible there. One thing that's not that flexible, the restore of a SQL Server database always recovers the database. And that's an important consideration. Remember that the restore of a SQL Server is a two-step process. The restore when data files and logs are put back on the server, and the recovery, which actually does the roll forward of the transaction logs and brings the database to a consistent state. Once that recovery takes place, no further restores can be applied against the database. What this really means, the long and short of it is that when we talk about using VMware policies to protect SQL Server, only point-in-time restores are possible, not restores right up to the point of failure. When you use the NetBackup agent for SQL Server, you're going to be doing continuous transaction log backups, sometimes very frequently, like every 15 minutes. And so if there's a failure, you can use those T-logs to recover right up to the point of failure. And that's not really possible with virtualized SQL servers using VMware policies. We can't configure T-log backups. We can only configure full backups. So my only recovery option is to restore the database to the point in time of my last backup. And that's a consideration that leads some folks to not use VMware policies, to stick with SQL Server policies instead. Install the NetBackup client in the VM and treat the virtual server like it was a physical server if those T-log backups are necessary. And this is all going to be driven by your recovery point. If your recovery point mandates that you need to be doing very frequent T-log backups, you can't do it with the VMware policies. You have to use the SQL Server agent. Again, it is not possible to apply T-log backups that you may have to a database that has been restored from a VMware backup. Application-aware VMware backups using VMware policies are always recovered, and further restores are not possible. Here's some limitations on using VMware policies to protect SQL servers. First bullet point we already mentioned on the previous slide. Point-in-time restores are not supported. It's not possible to restore additional incremental or T-log backups to the recovered database. Also, the SQL servers must not be clustered, and the use of the NetBackup VSS provider is required if you want to truncate logs. Honestly, it's a good idea to use the NetBackup VSS provider whether you're doing log truncation or not. Here's an example of restoring SharePoint from VMware backups. Again, even though we used a VMware policy, when we open up the bar console to do the restore, we're going to use the SharePoint policy type. That's our way of telling the bar tool that we're looking for SharePoint data. And all the normal restore options are available. You should be able to drill down and restore any database or sub-object that's supported for restore, including granular objects if you're set up for GRT. Some limitations when using VMware policies to protect SharePoint. Consistency checks of SharePoint are not performed as part of the backup. The backend SQL servers must not be clustered. And some SharePoint configurations serviced by SQL servers supporting multiple farms are not supported. And for more details about that last point, there's some good examples in the NetBackup for SharePoint Administration Guide. This is the Using NetBackup Accelerator for VMware topic. NetBackup Accelerator is a technology that allows full backups to run in about the same amount of time that incremental backups would. It's covered in a lot of detail in the basic administration course, but the focus there is on using Accelerator for standard and Windows policies, regular file system backups. NetBackup 7.7 also supports using Accelerator technology for VMware policies. And the idea is still the same. We're going to get a much faster backup by being able to quickly identify changes to the virtual machine and by making sure that changed data only is sent to the NetBackup media server and protected. Now, the mechanism is slightly different for VMware policies than it is for file systems. In file systems, we use a track log on the client to track changes to the client, and Accelerator compares the current state of the file system to the track log. In the case of VMware, we're going to make use of VMware's change block tracking feature to quickly identify changes to the virtual machine, and then compare that to a state file that's maintained on the NetBackup master server. And so the effect is the same. We rapidly identify what parts of the virtual machine have changed. We're operating at a very granular level here at the file system block level, and only changed blocks need to be transferred from the client to the media server. And then the media server is going to synthesize a full image within the dedupe pool. Like the Accelerator for file systems, Accelerator for VMware is supported only in dedupe pools, and only in dedupe pools that specifically support the Accelerator for VMware feature. Veritas pools do. Third-party OST might or might not. Check the hardware compatibility list to make sure. Now, the result is that we get a full backup in about the same time it would have taken to do an incremental backup. So this is a tremendous performance enhancer. It also gets us around some of those limitations for application-aware backups we were discussing in the previous topic. We have to do a full backup if we want to do application protection for Exchange, SQL Server, and SharePoint, but Accelerator is going to be able to do that in much less time with much less data movement. Here's a visual look at what happens during accelerated VMware backups. Accelerator for VMware uses a state file which is stored on the master server. And so unlike Accelerator for file systems, where we have a track log on the client itself, we're not keeping anything on the virtual clients here because we want to keep them as thin as possible. The state file lives on the master server, and it gets transferred through the media server to the NetBackup backup host at the time the backup job starts. Note that in many cases, the NetBackup backup host and the media server will be the same host. That's the most efficient way to do your VMware backups, but just for purposes of having a good example, we made them separate hosts here. And so VMware is going to be maintaining change block tracking on the ESX server that runs this virtual machine, and as the VM changes, the blocks that were changed are logged by CBT. During a backup, those changed blocks are the ones that are read and sent to the media server by the backup host and written to dedupe storage. Once all the blocks have been written, a full backup will be synthesized within the dedupe pool. Synthesizing the full backup is done by processing the changed blocks with the records of the last full backup. And then that metadata in the state file is updated to reflect the current backup, and then the state file is passed back up to the master server where it's stored. Again, the function of the state file in these backups is similar to the track log that's used with regular Accelerator backups. And so we get our full backup here in about the same time it took to do an incremental with CBT, which is very fast. We moved a lot less data across the storage network to the dedupe pool, and the backup is stored as a full backup, which makes recovery more efficient. The state file performs a similar function that the track log would in an accelerated file system backup. As we mentioned, this state file is going to be stored on the master server, and it's going to contain information about each extent of data on a virtual disk. 24 bytes of space is needed for each extent on the disk, and the number of extents per virtual disk depends upon a lot of factors, including disk fragmentation and allocation type. As a general example, there's usually about 1 to 3 kilobytes worth of state file for every gigabyte on disk. And these state files get automatically cleaned up if the image is expired, and they're transferred from the master server to the backup host by the BPFIS process, something you really only need to know usually if you're troubleshooting. The prerequisites for Accelerator for VMware are that NetBackup 7.6 or later is running on the NetBackup master server and the media server, and if the VMware backup host is a host other than the media server, then that client also needs to be running NetBackup 7.6 or later. Which platforms are supported is the same as for non-accelerated VMware backups. On the VMware side, ESX Server 4.0.3 or greater is required. That's to make sure we don't run into older versions that have bugs with CBT. And this feature uses the NetBackup DPO, the Data Protection Optimization license. And again, we're using Accelerator always with dedupe storage. And so if you've got dedupe storage, you've got the DPO license key because it requires it. Here's an example of configuring a VMware policy to use Accelerator. The policy type is VMware. I have confirmed that the storage unit is a dedupe pool that specifically supports the Accelerator for VMware feature. And I hit the Accelerator checkbox. And that's it. Nothing more to it. Note that if you take a look at the VMware tab in a policy that's using Accelerator, you'll see that Enable Block Level Incremental Backups is checked off and cannot be deselected. When using backup policies that use Accelerator, there is an option to create a full backup schedule with the Accelerator Forced Rescan option selected. Now, in Accelerator for VMware, this has the same behavior as it does for Accelerator for file systems. It causes the entire data set, in this case the entire virtual machine, to be backed up, and so you've got 0% Accelerator optimization. And it's primarily provided as a safety feature, just to make sure that somehow some change to the virtual machine didn't sneak by VMware's change block tracking. Theoretically, this should never happen, but it's good to have another level of security as a just-in-case. Now, obviously, this should not be selected on every schedule. If it's used at all, it should be run at regular but not necessarily frequent intervals. Now, one difference between Accelerator for VMware and Accelerator for file systems is that the use of schedules with Accelerator Forced Rescan is not mandatory. With Accelerator for file systems, you have to have a schedule with Accelerator Forced Rescan selected. With Accelerator for VMware, you're not required to have it, but we still recommend that you do, and that you do it once in a while. This slide here is recommending maybe once every 6 months or so, just to make absolutely sure we're not somehow missing something, and that's not a bad idea. In this lesson, you learned how to perform application-aware backups using VMware policies, and you also learned how to configure NetBackup Accelerator to optimize the performance of VMware backups. This concludes Lesson 9.